sides and the angle between those two. So 2 sides and the angle that's not opposite either of them. Good news about this one, there's always one solution. Always one solution. That is awesome. We don't have to do any testing or anything or thinking about it. We just use the law. Okay, so let's do a few examples. Here's what the law of cosine says. Now notice it has 3 different equations here, 3 different formulas, and that just depends on what angle you're looking for. In general, you'll have an angle or you'll have the side. You won't have both. Okay, you're not going to have the angle and the side opposite. You'll just have, in this case, the angle, and you'll be looking for that opposite side. Okay, so what you do is you do the side you're looking for that's across from your given angle squared, plus the other 2 sides squared and added together, minus 2 times those sides and the cosine of your given angle. Okay, so this is all of your given information on this side, and this would be the length of a side you're looking for. After using the law of cosines, then to find the other parts, you can revert back to the law of sines. Okay, so just because generally it's a little bit faster. So if we were to draw a picture of our triangle here, remember that the angle is opposite the side, angle opposite the side, as far as their names go. We know that A is 5, we know that B is 8, and we know angle C is 115 degrees. Now obviously this is not drawn to scale, it's just a sketch to keep me focused. So here what I'm going to do is, this is the side I need to find, so I'm going to have that side squared, which for now it's just C, equals the other 2 sides squared and added together, so 5 squared plus 8 squared, minus 2 times those 2 sides again, so 2 times 5 and times 8, and then times the cosine of our angle, which was 115. Now notice on this side, all we're going to need to do is to calculate this. You may be able to put the whole string in your calculator and feel good about that. Always double check. I'm going to go one kind of a little bit of a time. So 5 squared is 25, 8 squared is 64, and then multiply that together. 2 times 5 times 8 times the cosine of 115. And what happens is I have this -2 and cosine 115 was negative, so this becomes positive. If you take -2 times 5 times 8 times cosine 115, you get plus 33.8. That doesn't happen every time. Depends on the size of your angle. Now add those together. (25 plus 64 plus 33.8 gives me 122.8. And finally, all I need to do now is take the square root of both sides. And I get about, I'm going to round to the nearest tenth, 11.1. I get 11.08, but I'm going to round that to 11.1. Okay, so I found my missing side. Now I need to find those last 2 missing angles. To do that, I'm going to go back to the law of sines. You could use the law of cosines, but the law of sines takes less room on my paper. So that's what I'm going to do. Okay, so you want to pair up. Remember, law of sines, we pair up the angle with its opposite side, and we do the length of the side, so in this case 11.1, over the sine of our angle equals, pick which angle you want to find first. It really doesn't matter. I'm going to find angle A, so I want the side opposite angle A is 5 over the sine of angle A. We need to solve for A, so first I'm going to cross multiply so I can get it out of the denominator. That gives me 11.1 times the sine of A equals 5 times the sine of 115. Again, we're trying to isolate the A, so we divide both sides by 11.1. And so far we have the sine of A is 5 times the sine of 115 divided by 11.1, and that gives me 0.4082. I'm just leaving that in my calculator because remember we need just A, so to remove that sign there we do the inverse which is the arc or inverse sine. So in our calculator, we do the inverse sine of 0.4082, or the number I just left in there again, because the less rounding I found, the better off you are. I get about 24.1. Okay, so angle A is 24.1. My C is 11.1, and now we need to find angle B. For angle B, we're going to use the fact that the angles in a triangle add to be 180. We already have two of them. Let's subtract them from 180 to find out how much is left for our final angle. So together, so far, we have, if I add the two angles together, so far there's 139.1 degrees taken up. How much is left to get to our 180? 40.9. Okay, so my last angle, my angle B, is 40.9 degrees. So to find our side, we use the law of cosines. Then we use the law of sines to find one more angle. And finally, we use the triangle angle sum theorem, or the fact that the angles in a triangle add to be 180, to find our last angle there. Okay, I have one more example here. You can try on your own, see if you get it right, or just walk through it with me. Okay, so again, we have the case where we have two sides and the angle between them. Okay, so we're missing the side across from them. We draw our triangle, angles A, B, and C. Side C is across from C, side A is across from A, and side B is across from B. We know that A is 10. We know that B, well, we don't know B, and C we know is 14. And we know angle B is 44 degrees. So again, we're set up here for the law of cosines. Okay, so here's our known angle. We start with the side opposite that known angle, the side squared. So just B for now, equals the other two sides squared and added together. So 10 squared plus 14 squared, minus 2 times those two sides multiplied together, times the cosine of our angle. We just need to calculate this right-hand side. Okay, so 10 squared is 100, 14 squared is 196, and then we calculate negative 2 times 10 times 14 times the cosine of 44 is negative 201.415. That's what I'll count it off as. Combine those, 100 plus 196 minus 201.415. And I get B squared is 94.585. If I take my square root, I will know what B is. Right, I get that B is about 9.7. So I found my missing side. B is 9.7. I'm going to use the law of sines to find angles, either angle A or C. It doesn't matter which. I'm going to find A. So again, using the law of sines, the way that we set that up is we do the length of the side, so we know our B is 9.7, over the sine of angle B, which we knew was 44, equals, I'm finding A, so I'm going the length of side A, over the sine of that angle, which I don't know the angle. Okay. We want to get A by itself. It's in the denominator, and it's with the sign, so we start by cross multiplying to get it out of the denominator. Okay, next we divide both sides by 9.7. And I get the sine of A equals 10 times the sine of 44 divided by 9.7. That gives me that the sine of A equals 0.716 approximately, and I do the inverse sine so that I can find the measure of the angle. I have the ratio of the sine, I need the angle. Okay, so A is the inverse sine or arc sine of 0.716, which gives me about 45.7 degrees. So angle A is 45.7 degrees. And now I don't have to use sine or cosine. I just use the fact that the angles in a triangle always add to be 180. So far I have a 45.7 degree angle and a 44 degree angle. So far I've covered 89.7 degrees in that triangle. If I subtract from 180 what I already have, that will give me what's left over. So angle C is almost a right angle. It's about 90.3 degrees. Okay, so I found all the requested missing parts.